mole of an ideal gas undergoes reversible isothermal expansion from initial volume V1 to a final volume 10 V1 and does 10 kilojoule of work. The initial pressure was 10 to the power 7 pascals. Calculate the value of V1. Solution of this question is, since gas is undergoing expansion, hence work is done by the system, therefore W must be negative. So we can write minus 10 into 10 to the power 3 joules equal to minus 2.303 into 1 into 8.314 into T log of P1 upon P2. Mark it as equation number 1. Also using P1 V1 equal to P2 V2, therefore 10 to the power 7 into V1 equal to P2 into 10 V1. Therefore P2 becomes 10 to the power 6 pascals. Hence putting P1 equal to 10 to the power 7 and P2 equal to 10 to the power 6 in equation number 1, we have minus 10 into 10 to the power 3 equal to minus 2.303 into 8.314 into T log 10 to the power 7 upon 10 to the power 6. Solving this we get T equal to 522.27 Kelvin. Now apply PV equal to nRT for the gas at the initial position. Therefore 10 to the power 7 pascals into V1 in terms of meter cube will be equal to 1 into 8.314 joules into 522.27 Kelvin. This gives V1 equal to 4.34 into 10 to the power minus 4 meter cube. Since 1 meter cube is equal to 1000 liters, therefore V1 becomes equal to 4.34 into 10 to the power minus 4 into 10 to the power 3. That is equal to 0.434 liter, and that's the answer of this question. B. Work done in isothermal irreversible process. Here the following two cases arise. Number 1, expansion against the zero pressure or free expansion. Remember, W does not depend on the pressure of gas, but it depends upon the opposing pressure. Therefore, W equal to minus P external into delta V, but P external is equal to 0. Therefore, W is also equal to 0. Further, since temperature is constant, hence delta E is equal to 0, and therefore Q or dQ is also equal to 0. Number 2, expansion or compression against a constant pressure. Using the formula W equal to minus P external into V2 minus V1. Let initial pressure of the gas n moles be P1 and P external equal to P2 and temperature be T Kelvin. Then W will be equal to minus P2 into nRT upon P2 minus nRT upon P1, and that's equal to minus nRT within bracket 1 minus P2 by P1. Therefore, In case of expansion, where P2 is less than P1, W will be negative. And for compression, where P2 will be more than P1, W will be positive. Here is an important note. Here we find that W expansion and W compression will be different in magnitude, while in case of reversible process, it was not so. Let us solve the following numerical to illustrate it. Here is a question. 5 moles of an ideal gas at 300 Kelvin are expanded isothermally from an initial pressure of 4 into 10 to the power 5 pascals to a final pressure of 1 into 10 to the power 5 pascals against a constant external pressure of 1 into 10 to the power 5 pascals. Calculate the amount of work in joules done by the gas. Also calculate the value of work if the above expansion would be reversible at the same temperature. So we have solution A for isothermal irreversible expansion. Since W is equal to minus nRT into 1 minus P2 by P1, substituting the values, W becomes equal to minus 5 into 8.314 into 300 into 1 minus 1 into 10 to the power 5 over 4 into 10 to the power 5. That's further equal to minus 5 into 8.314 into 300 into 0.75. That on calculation gives minus 9,353.25 joules. That becomes one answer. Then solution B. If the expansion is reversible, then we know formula for W is minus 2.303 nRT log P1 upon P2. Substituting the values in this, we get W equal to minus 2.303 into 5 into 8.314 into 300 into log of 4 into 10 to the power 5 upon 1 into 10 to the power 5. That on calculation gives the value of W equal to minus 17,291.6 joules. That becomes another answer. It is also clear from the results that magnitude of work in reversible process is always more than that in irreversible process.